This is 3.1 notes, page 3. Now that we've looked at the three forms of the standard difference quotient, we need to know when do I use what formula. And it all depends on whether you know the value of x or not. Let's say that you know a specific x value you're interested in, so you'd follow this path. There's actually two choices to use in that case. Both of these choices, they both involve the a value, which is your value of x you're looking for. This is kind of most similar to the one we learned first, with where h is approaching 0. Usually this is harder to work through just because, you know, it has the a plus h, especially if it's a squared, if it has x squared in it or x cubed in it, this is going to be a little bit harder to work through. But it, you know, if you do your work right, it'll come out in the end the same as this one would. This is our newest one. And this, instead of looking at h, we look as x approaches a, or the value you're interested in. A lot of times this is straightforward, and this works out quite nicely. Occasionally you'll get a problem that this is messy, but a lot of times this is the best method. Remember, in either of these, you have a value of a that you're interested in, so you plug in that value of a right at the start of your limit work. Now, if you don't know what value of a you want, or don't know where you want the tangent line to be drawn, then you would just have, be left with this as your only choice. You would use this function, you use this expression, you put x plus h into your function. This gets a little messy too. Just bring in x along for the ride. It stays in the whole problem. And when you're done, this is the one that will result in an equation of the slope of the tangent line. Once you get the equation, you could graph it. You could plug in any value of x that's valid, and you could get your slope of the tangent line that way. So we've used the first two examples quite a bit. Let's do an example using our newest method. So I'm going to use this function here. I want to find f prime at 4, the slope of the tangent line at 4, for this function. So I always like to start by writing out my limit expression. So I have the limit as x approaches a. Well, actually, instead of a, let's go ahead and plug in the value that we're headed toward. That's what I meant to do. So we know the x value we're interested in is 4. So the limit as x approaches 4 of, and we'll put in f of x. Let's bring this down a little bit. We'll put in f of x, which is just the function as is right here. 2 over root x minus 1. And we subtract out f of 4 all over x minus 4. So basically all I've done so far is just plug in the value of a. Now we'll clean it up a bit. Limit as x approaches 4. The function I want to leave as it is right now. What is the function value at 4? If I plug in 4 to this original value, f of 4, I'm just going to work up here for this. This is 2 over square root of 4 minus 1. So it's 2 over 2 minus 1. That's just 0. So it's this function value minus just simply 0 over x minus 4. I actually don't even need to show this minus 0 part. I'll just rewrite it real quick. At least this way we can see we considered what the value of that was. Alright, so now I need to clean that up. I have a fraction within a fraction. That's no good. So the first thing I want to do is clear the fraction out of the numerator. The best method to do that is to get a common denominator here in the numerator and multiply by that on the top and bottom of this expression. So when I multiply by square root of x, I'm going to distribute that to the numerator. So I get the limit as x approaches 4. X times this just leaves 2, minus 1 times root x is just negative root x, all over, the denominator got a little messier, square root of x times quantity x minus 4. Okay, I still have a denominator issue though, because I can't plug in 4 without getting a 0. So I need to clean it up further. And if you remember, a technique that works nicely when you have a radical in the numerator is to multiply by the conjugate of that. So I'll multiply top and bottom by 2 plus root x. That way when I FOIL the numerator, it gets cleaned up quite a bit. First term's 2 times 2 is 4. Inside term, negative 2 root x. Outside term, positive 2 root x. Those go away. Negative root x times positive root x is just negative x. All over root x. X minus 4. 2 plus root x. Okay. So ultimately I'm trying to get rid of the x minus 4 in the denominator. And I don't have an exact match here. But it's only the signs that are different, which means it's off by a factor of exactly negative 1. I'm going to eliminate these, but instead of just putting 1 in the numerator to replace that, it's going to be negative 1. So I'm at limit as x goes to 4 of negative 1 over whatever's left here, square root of x times 2 plus root x. And now I'm able to substitute that 4 in and figure out what we have. Negative 1 over square root of 4 times 2 plus square root of 4. What do we have? That's going to be negative 1 over 2 times 2 plus 2. That's negative 1/8.